Okay, hello everybody. This is the AMA session for presenting a solution of new foundation for the contest of Solidity to TVM Compiler using Groth16 zkSNARK proof verification instruction support introduction. And yeah, we are starting. Please, Mikhail.
All right. Well, that's going to be just a little presentation for, a full patch to the Solidity compiler, which will, as Anush said, it introduces the possibility to use the verification instruction from Solidity. I mean, it's done like just as a member function to the TVM statement, and well, it's done just as hashing instruction call is being done. Well, just like exactly the same way actually, because it even accepts the same arguments to itself, like just the self, right? And well, just a little presentation. It's going to be damn boring, but let's go. All right. This is the last version of a compiler from our repository. You see the Git tree at the top. Well, it's just for a little verification, right? Now let's build it. I've pre-built it already, but well, just as a formal thing, let's go for some example code. All right, it's a regular Solidity compiler. Here it is. Just built it. The commit, you can see it's the same commit identifier. So here we go. And let's take a look at the example code we're having in here. That is how it's being used. Well, pretty trivial thing. It is supposed to accept the byte blob of, a serialized byte blob of a proof as the input. Well, simply builds a cell, which is being passed to the TVM member function, which now has something like this. Well, it can be renamed if someone thinks if someone think the name is ridiculous, it can be renamed. But I see no point in that. It just complies with the instruction name. All right. Well, that's the example code we're gonna compile. Let's do something. Yeah. Let's remove what we have had here before. Just for the clarity, and do compilation actually. Well, all right, just a warning, syntax warning. Nobody cares about it. Here we go. We got a compiled ABI. We got a compiled code. Let's take a look at that again. All the same, nothing changed. Verification, let's take a look at the code. Here we go. Here's the instruction. Here's the here's the builder calls, etc., etc. And here is the ABI. Well, just nothing really changed. Well, here we go. That's the compiler demo.
And linking?
You want to see the linking? We gotta go for the
TVM link.
Yeah. We gotta go for the development environment to do that. Take a look. Let me take a look where it's possible to do that right now. Let me take a look. Yeah, I gotta prepare it separately in case you want to do that locally. Well, let's build it. Yeah, great. Well, it's gonna take a while. I didn't build it. Yeah, sorry. Didn't prepare that.
So what do you want to demonstrate, or what is Sergey asked to demonstrate is we could link it and receive a binary code which we could put network provided by NIL Foundation, and it will run inside that network without any issues after using the Solidity compiler. Correct?
You want to see the full cycle?
Yes.
Yeah, and could you please explain a little bit more about this opcode and about input data? Do we really need to kind of wrap it in TVM cell? Maybe we can just use it as a byte, speaking about Solidity terms.
Yeah, this it's like the full. All right, let's one by one. Full cycle. Well, it's going to be prepared a little bit. Let's postpone it a little bit. I wasn't prepared to show. I wasn't prepared to show the full cycle right now. It's being built, as you can see. It gets built. So when it will be done, there will be a linking stage and etc. etc. Coming to Solidity constructions, well, yeah, this opcode accepts the serialized Groth16 proof. What is this? What it is exactly? It's not only the proof itself. Well, the proof itself is one moment. Something has happened. Nothing really special. Sorry, I'm gonna take it back again. Here we go. The opcode accepts a serialized proof as an input. It's not only serialized proof, actually, it's also about the primary input. It's about what the proven part gets proved, actually, well, the statement. That's the first thing. And the second thing, well, and the second thing, it accepts the verifying key, the serialized verifying key. Well, in the end, this takes, I mean, well, several kilobytes, depending on the primary input size, depending on the proven input size. That could take like a lot of space, actually, in case we're proving something really big. The proof itself is 1.5 kilobytes. The verification key is like, well, within the kilobyte. And the proving statement is like probably infinite. Why it is done as well, except in the cell, just because it was like a pretty effective way to deserialize it from the cell inside the virtual machine to the proof, well, to the actual like proof data.
Yeah, but excuse me, it is stored. It should be stored in the reference of the cell, of the input cell. Yes, because in this example, you were kind of storing your bytes in builder, and it's usually stored as a ref, and then you kind of put it to your function. Yeah.
Yep.
But is it really was easier to store it in the ref, but not in the cell itself?
That could have been done. Well, you're right. Maybe
because
reference,
it seems like
maybe the reference could be easier, right?
No, we've got that in a reference now, as I can see.
You mean to put it inside the cell itself? It never.
Yes.
It will never fit. Just forget it. I mean, it's too big.
Why? Because a reference is also a cell, and you put it in a reference. That's the same cell which you can put it in.
Yeah. Okay. Yeah.
That's what I mean.
I got what you're talking about. Yeah, I was thinking. Yeah, I was thinking.
In this
like,
realization, we've got an extra load ref to kind of get these data from the reference. Yes.
that's right. Well, yeah, you're right. That could be done actually.
Yes, and speaking about Solidity compiler, my colleague and we had a look on it, and we should say that it's better. Can we kind of do some, give you some
Advice? Sure. Here we go.
No advice, not advice, but feedback. Yeah, feedback from our side.
Here you go.
Yeah, that you have added some intrinsic function, and that's a little bit old mechanism, and you've added an API function like TVM.member function. Yeah,
Yep.
that's what we call API, and it's better to remove this intrinsic function and leave only API, and and we find it almost necessary to organize the work of this command, of this function, that it should work only if a special pragma was placed in the contract, because this opcode is not an ordinary opcode, yeah, and you shouldn't be able to use it for your different ordinary contract.
Well, I mean, yeah.
Do you understand?
Yeah. I got it. I got what you're talking about.
Yeah,
well,
we advise to use something like pragma, nil mod features, or something like that. That these pragma would enable you to use these function. Yeah.
I got a question. I mean, it's like, all right, coming to the first point, I got it. Well, the additional function was added just as you know, yeah, just as a fallback option. You're right. I saw the warning that it's deprecated. Well, all right, it can be removed, like no problem. The second point is, I mean, why do add the special mode? Because, well, the virtual machine is going to be updated eventually, and we're not talking about putting this compiler into master branch of a Town Labs repository right now. So, I mean, well, or do you want to put it into the master branch of Town Labs repository right now?
No, okay. If you don't want to kind of release it right now, that would be okay. We just don't want to have this feature in our master if it is not supported by an ordinary node. If it will be released just after node update, that's okay. That's okay. Yeah.
I got it. Well, all right. Then, well, looking at the pragma then, no problem.
I think we can just use pragma like and originally Solidity has pragma experimental features, something like that. Just to, if you want to use it now, yes, if you understand.
Yep, I got it. Well, all right. This can be added. All right. Into the full demo. Let me ask if the cluster is up and running right now, because folks were launching it. In case it's up and running, we could do the full demo.
And also, excuse me, colleagues, remind me that we've got some code style with indentation of tabs and spaces, and please, we ask you to follow it.
Yeah, okay. I tried to follow it actually, but it looks like I screwed up somewhere. My bad.
Okay.
All right, I'll fix it.
Thank you.
One moment. Looks like the cluster is being redeployed. At least a couple of nodes. Apologizes, guys. I don't think the full demo is possible right now because we're having the cluster redeployed. It's gonna be the compiler demo only.
Could you repeat, please? What's wrong with cluster network?
It's been redeployed. Just wrong timings, nothing really special.
Okay, and did I understand correctly? You are going to follow the recommendation,
Sure.
recommendation that we have, and this way, this example should be changed as well. So this way, we should change the way we are using this instruction. Did I understand correctly?
It's not like the way which we use the instruction, but the example itself will be definitely changed. That's right.
I mean, the way we will use this function TVM method will be different.
No. No. If we talk about this particular thing, well, the deprecated functions usage will be removed from the compiler. But this particular example, it uses the most the most modern way of running things. So the call of how it's being used right now will not be changed. Well, maybe except the thing with the cell reference.
Yeah, my question is about the solidity itself. So not but inside the solidity will be used this way, or the way will be changed.
It will be used this way.
Got it. Thank you. Any other questions, guys? Again? Five, 4, 3, 2, 1. Nobody. Okay, I think it's enough. It's a good presentation. Thank you, Mikhail. That's all. Thank you,
Right.
everybody.
Thanks for the feedback, guys.
For feedback, yeah. Great.
Thank you for the presentation.
Bye. Bye, everybody.
Thanks.
Bye-bye.